In order to understand the cycling of elements throughout the oceans, we need to have a basic understanding of the nature and circulation and physics, physical properties of the ocean. And so, just some basic facts. The ocean covers 71% of the global surface area. So it's got about 362 times 10 to the 362 million square kilometers is ocean, whereas the total Earth surface is only about 510 million square kilometers. So it's a big fraction, and that's why they describe the Earth as sometimes the blue planet. On average, it's got a depth of about 3.7 kilometers, or 3,700 meters. Often oceanographers are speaking in terms of meters, and that depth is distributed. If we look at, we can often think of it as like a wine glass, or in the sense that much of the something like this that if this is depth on this axis, and this is the width of this graph is the concentration or the relative abundance. Most of the ocean falls in this mid water depths in the abyssal plains, where we've got anywhere from 3,000 to 5,000 meters of water depth. The continental shelves represent only a small fraction of the total volume in the ocean, and the deep ocean trenches are also a very small fraction of the total ocean volume. Nonetheless, a lot of the important physical transformations and chemical transformations are taking place especially at that surface upper boundary, or along the sediments. We describe the density of seawater is also important. The density is described with the term rho, and it ranges between 1,022 to 1,028 kilograms per meter cubed. And it seems like it's a small relative range, but it turns out that these small differences in density play a large role in stratifying the ocean. And the oceans are strongly stratified such that we have, if this is the surface here, write it in blue. If this is the surface here, and below that we've got different layers, where we've got lower density waters over higher density waters. The differences in stratification and in density between these different layers prevents mixing and transport from going in this direction. So that doesn't really happen. Instead, what happens primarily is that waters are transported along lines of equal density, and so we get these elongated spatial patterns, elongated horizontal patterns of tracers and physical and chemical properties throughout the oceans, and strong vertical gradients in ocean properties. And so this is often something to keep in mind. Oftentimes when oceanographers, and in this class we'll be discussing a lot of horizontal transects of ocean properties, where we've got a distance along the top and a depth along the vertical axis. And what that one thing to keep in mind is that in those plots, we are often greatly exaggerating this vertical aspect ratio, because we're talking about a few, on the order of a few kilometers in this direction, but in this direction we're talking about large ocean basins that are spanning thousands of kilometers. So in order to visualize this, and because of these physical properties of the oceans, we often stretch and compress these, or stretch in the vertical direction and compress in the horizontal direction, these horizontal transect plots.